Okay, moving on to example 6. You'll see we have a rational inequality here. Probably easiest if we subtract 1 from both sides. Okay, we do that, we get this. Now, before we can start factoring, we want to combine this into one single fraction. And how do we do that? We do the thing with the common denominator, right? So we can take 1 and multiply it by x minus 2 over x minus 2. Okay. Or, oh, I'm sorry, we don't want that. We want x minus 4. Okay. X minus 4 over x minus 4. So this will become x plus 2 over x minus 4 minus x minus 4 over x minus 4. Okay, to be greater than or equal to 0. And now we have a common denominator, so this will be x plus 2 minus x minus 4 over x minus 4. Okay, now notice I put parentheses around here, and this is very important because this is where people can make a lot of mistakes. Because we're subtracting everything in this fraction, though it means we're subtracting everything in this numerator. So we're not just subtracting x, but we're also subtracting 4. Okay, so now what does this become? This becomes x plus 2 minus x plus 4. Okay, over x minus 4. Okay, and now we can see the x's will cancel, and then this just becomes, this will be 2 plus 4, that's 6. All right, now we have a nice single fraction on one side and a 0 on the other. And all right, so now what do? We want to, well, the only factor here is 6. Okay, that's not really going to contribute anything. We can make a sign chart if we want where it's positive everywhere. 6 is positive everywhere, right? But it'll never be 0. And then x minus 4, that goes from negative to positive. And then we can see that this is going to be negative when positive times negative is negative, positive, positive, positive. And we want this to be positive, so what we want. And we will see that if we plug in 4, of course, this is undefined, so we do not include that. So our answer is just going to be the numbers from 4 to infinity. Okay, moving on to example 7. Okay, this is another, we're back to a polynomial inequality. I'm going to pause the video. You can pause the video and work on this because this is very similar to one of our other examples. So I'll let you work on this for a minute or two. All right, and here's our work all of a sudden. And hopefully you factored this correctly as x plus 5 times x minus 2, x plus 5. Both these factors go from negative to positive. We're first at negative 5, second at 2, and we can see that so this product will be positive when x is less than or equal to negative 5 or greater than or equal to 2. All right, moving on to example 8. Once again, we want to try to put everything on one side, and I'll leave it up to you. Let's see, I'm going to just take this and move it over here just because we wanted to. So this means that 0 is less than 2 over 3x plus minus 9 minus 1 over x minus 2. Okay. Once again, we're going to try to combine this with a common denominator. That means we have to multiply and divide this by x minus 2 and multiply and divide this by 3x minus 9. Okay, the 1 is kind of out here. Okay, now combine this. Now the whole point, we have a common denominator, so we're not going to multiply the denominator out. We don't want to do that because the denominator is already factored. And what will be up here is 2x minus 4 minus 3x plus 9, once again because of the parentheses here. It's 3x plus 9. So this will end up being 2x minus 3x is minus x, and then negative 4 plus 9 is positive 5. And we can rewrite this as 3 times x minus 3, because we can factor out of 3. So this will be 3 times x minus 3 times x minus 2. Okay, and we can see that the interesting points where where the factors are 0 will be at 5, 3, and 2. Okay, we can make a sign chart for these 3 factors. We don't really need to make a sign chart for 3 because that's just going to always be positive. That won't affect anything. So here's 2, 3, 5. Minus x plus 5, that goes from positive to negative. X minus 3 goes from negative to positive. X minus 2 goes from negative to positive. There's 2, 3, and 5. And we can see that this first interval is positive, negative, positive, negative. Okay? And we want the way we chose this, we want this expression to be positive. So we want this interval and this interval. Okay. So finally, which ones do we include? Well, back in here, if we plug in 5, actually we don't include any one of them. We can plug them back into the original inequality, but because this is strict, we don't. If we plug in 2 and 3, these will be undefined, and if we plug in 5, these will be equal. So that we don't include that. So we want strict inequality. So our final solution will be negative infinity to 2 union 3 to 5. Okay, last one. We'll pull the 7 over here. That is, subtract 7 from both sides. Okay, and now we have 3 terms we want to add. We need a common denominator. Looks like since the only denominator we have here is x, you probably multiply everything by and divide by x. So, okay, and if we do that, this becomes x squared plus 12 minus 7x all over x. And I'm going to just rewrite this, so this is going to be a little easier to factor. This is x squared minus 7x plus 12 over x. Okay, I'm going to let you pause the video again, and we'll finish up. Okay, hopefully you were able to factor this okay. This factors. This is x minus 3 times x minus 4. So we have a plus 12 here, and we still have an x in the denominator. Here are our 3 factors, x minus 3, x minus 4, and x minus 0. So the interesting points will be at x equals 3, 4, and 0. We make a sign chart for each factor, and then a final sign chart for this expression. We can see on this interval negative, 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 positive, positive, negative, positive, 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 positive. Okay, and what do we want? We want this to be strictly less than 0, right? So we want the minus intervals. Okay. And obviously this is going to be undefined at 0, and at when x equals 3 or 4, this is 0. 0 is not less than 0, so we don't include that. So we actually we don't include any of these. So our solution will be negative infinity to 0, union 3 to 4. All right. Now it'll be your turn to try all this stuff out on the homework.